Okay, everyone. So now we're actually going to be looking at constructors and getting into some serious coding with our objects that we're going to be making. And the first thing that we're going to use is this type of idea of an init or an initializer. Now, this initializer is actually ran every time that you create a class. So we've already been running a constructor for our class. We just haven't seen what it actually looks like. Now, on a previous lecture, we've noticed that we saw some definitions like add and subtract when we're doing x dot underscore add. And what I want to focus on is when you see these two underscores, that denotes that it's built into Python. So anytime you see two underscores, they're going to be either overloading a built-in Python operator or doing a definition that's not a part of our usual made up ones. So now what we're going to do is after we have these two underscores, I'm going to type in the words init, I-N-I-T, and then that's going to be followed by two more underscores. This is a constructor in Python. And after you add in the init, of course, as we're used to, we're going to add in this self parameter because we need to make sure that we're looking at only our own instance. And then we can finish that up and then put in our colon. Now, after we do this, you're most likely going to want to put in the version 1.0, like so, to be tabbed in underneath this. And to make this a fully unique class, and this is what you'll be doing on the homework as well, any attributes that you're creating that are going to be a part of your class should have the self.version in front of it. So now this self.version is going to be referencing the self.version up here, and it's going to be created whenever we make an object. To showcase what's actually going on inside of our constructor, we could say something like this. I'm going to say inside of my constructor, when I'm going to create a new class object, I have a print statement that runs for me. So if I say something like a is equal to my class, we'll get this ran for us. A.getVersion with my two parentheses, I get 1.0. A.setVersion of 15. Then I can do this again. Now I have it at 15. B is equal to my class. B.getVersion. Now we have it at 1.0. Cool. So this is what a constructor looks like, and this is the general idea of what you're going to be using. So a constructor is going to be created, and it's going to define the variables that you want your class to have access to. So if you need to have access to certain attributes, a part of a person or like hair color or anything like that as well, you'll declare them up here, and then you can get the methods down here to start running for it. Now, one more thing is that you might have seen this exercise down here where we want to add a parameter. And this is useful if you are creating for later on as well. We're going to add parameters into our class here. And essentially, very similar to what we did for our function when we have user version, what we could say here is something like version to take in. And what this will do now is, how about instead of setting its self.version equal to 1.0, I'm going to set it to what a user provides to me as the version. Now, if I do my piece of code to look like this, what will change inside of my code is that when I actually create my method, a is equal to my class, we'll notice that it actually asks for a version inside of here. What happens if I don't provide it? We'll actually get the missing required position argument error. This is similar to if you create a function with two parameters and you only provide one. This is the same error that occurs. So in this scenario, we need to make sure that we're providing a parameter. How do I provide a parameter? Very easily, I could just do something like 15.0. And now if I have a.getVersion, now it's updated. Cool. So self.version is equal to version is how we'll do this now. But let's just say that you're doing a lot of testing and you don't want to have to require the user to type in anything here. This is where default parameters or default arguments for our parameters come in. And what you're going to do essentially is in your parameter listing of version, if you put an equal sign after it, and then you go ahead and you provide a number, let's just say that the version is 2.0. There are a few things that are going to happen. If you create a class and you provide it the parameter of 1.0, you'll see it gives me that okay. But if you create a class, you'll notice here that it says version is equal to 2.0. If I close this off and I don't do anything else to it, it actually will default to whatever value I put in here. Does this need to be an integer? No, this could be true or false. It could be a string. testing. It could be whatever you want it to be because Python is very broad about that. But in general, you're going to have it set to that default argument. Now, let's just say that there's one more thing here that I want to add in. I'm going to add in another variable. I'm going to say self.name. Let's just say this is like a computer program. And what I'm going to say here is I want to also provide a name into my argument list. One thing with Python is that if we run this code, we're going to get this weird error that says non-default argument follows default argument. Essentially, if you want to provide a non-default argument or an argument that doesn't have a default value, you're going to need to put it before the default arguments. This down here doesn't matter the order of how you set them. That Python doesn't care. It does care if you set in a non-default argument. So this name doesn't take in any default values before one that is. So if I run this code now, it will run as expected. Now, of course, if I have this working, what I'll need to do now is provide it with Windows. And now if I actually don't provide it anything else, it will use the default value of version. Cool. And now that's at 2.0. So this is running okay. And let's just say that I want to make sure that this is also defaulted. So what I could say here is I can default this to test or something like that as well. Nice. So now what we're going to look at here, before we look at inheritance, the last main part that might be a little confusing here is the string representations for overloaded operators. So we're going to be taking a look at a few different operators that are going on, including a list operator later on as well. And essentially what is going on here is a string operation for overloaded operators is going to work with replacing what we see when we type print my class or we type out the my class by itself. What I mean by that is that if I do print of A, we'll see that we get this kind of nasty looking like memory address. If I just type in A as well, it's the same thing. Nothing really is going on for me. So what we could do inside of Python is actually create a method. And again, this is going to use the 2 underscores. If I type in def of underscore string underscore, what this will do is it will give me back the string representation. So when you print out an object, that's what is called. Otherwise, the REPR is actually the canonical string representation, or what Python represents. So what I could say here, actually, when I create this overloaded operator of string, this is going to try to return something, and what I'm going to return is just a formatted string of information of my class. So what I could say down here, when I type out return, is something like class, let me make it a string, class object, my class object with, let's see here, version. Let me call it with name and version. Cool. And I'm going to format this guy as well. And this is what you're going to be most likely doing on your assignments, something similar to this. What I'm going to format it is I want to provide it the version and the name. So can I just do something like this where I say version and name? Nope, because what will happen here is that Python will throw an error because name and version aren't defined in the scope of this namespace. Name and version are only up here in a parameter list. That's not inside of our namespace. What is in our namespace? Self.version and self.name. So whatever is declared here, everything else in your class has access to it. So if you want to do it this way, what you'll say here is something like self.name and self.version. Now, if I run my code again, we remember that previously we had a print of A where it gave me the memory address. Now when I print my A, I'm actually getting back this this representation of a print statement that looks a lot neater. And this is more useful for us to use in our code. Now, what was the other thing that we saw? What happens if I just type out A? It gives me the memory address. So how do I fix it where I'm typing out A and it's not giving me back everything? What I could say here is use this method called representation or REPR. And what I could say here now is return another type of string. Maybe I'll do it a bit differently. My class object, let's make this one like a bit more programmy looking with name, comma, and then version. And I'm going to format this one to take in self.name and then self.version like so. You'll be asked in the homework to probably do these in 2 different ways. So in one way, you're going to be printing it, and in the other way, you're just going to be representing it like normal. So if I do my class again and I print A, we'll see that I get the string representation back. And if I just type out A, I'll get the Pythonic canonical string representation of it. So A like so. Cool. So that's overloading a few operators. And can we only overload the string and representation? No, you can actually overload anything in Python. So one thing that we can try to do here now is how do we make a custom overloaded operator for adding two of my class objects? So let's say A is equal to my class, B is equal to my class, and what I'm going to provide it is, let's see here, I want the name to be the same. Now, an issue here is that if I want to change the version, I'm probably going to need to provide a name for it as well. So the name, I'll call it Windows. Version, I think we're on 12.0 or something. Let's just say it like that. I want to do A plus B, but we'll notice that if I do A plus B, I get an unsupported type operation for my class and my class. So how do I fix this? What we can actually do in our Python code here is create an overloaded operator for the addition function. Now, again, how do you remember what each of these are? You'll just type in help of a function and it will tell you, and usually we don't do much besides add and subtract. But what I'm going to do now here is I want to take the two versions of a Python object of two my class objects and add them together. So what do I need to do to be able to add two different objects together? Remember, if we take a look at my code, I did A plus B. What you need to do here is your parameter has to be other object. It doesn't need to be other object. You could say other my class object. You can do whatever you'd like, but we're going to assume that when you're adding two of these objects together, the other thing that you're going to be adding is one of these, right? Now, what I'm going to do here is I'm going to return the addition of the two versions. So now how do I get the version from my class here? Well, you can do something a bit easier where you could say return self.version. How about we actually call the method that we used to get version? So what I'm going to say here is I'm going to return my current instance's get version. So self.get version, so my version. And what I'm going to add it to is the other my class objects. And remember, if this is a my class object, what does it have access to? Literally everything inside of here. So if it has access to all those, what can I do here? I can actually do the get version on my other class object as well. Now, why do we have to do this parameter right here? What's going on in our code? Well, let's just see if this works first for us. Nice. So again, we get a 2 because it defaults to 2. And now we have a 2 and a 15, so we get a 17.0. I put 15 instead of 15.0. It's not a huge issue. How come when I do A plus B, I have to provide another my class object like this one? Well, what happens again, remember, add is actually this method here. And B is a parameter being provided. And that's actually what's running down here. So we do A.add B. Now let's do one more version of this where we do subtraction. So sub is your subtraction overloader. Now, if you're a bit picky about your names, you don't need to call this other my class object. You can call it other. Usually other is actually like the default way. If you look at GitHub or if you look at Stack Overflow, people use other quite a bit. So what we're going to say here is I'm going to return self.getVersion minus other.getVersion. And now what was the subtraction do for us? Let's try to see if this guy works. A minus B, negative 13. B minus A, 13. And you'll notice here that it doesn't care which one we're using. It's going to work either way because they're both my class objects. Awesome. So this is kind of making constructors and classes, and this is overloading built-in operations in Python with that class as well. And you'll see here that how do I tell what is built-in and what isn't? The double underscores here. So these guys I created myself. I just made these up on the fly. These ones are built into Python, and if you don't implement them, it will give you errors or it will give you a default returned value. Awesome. So again, please experiment a bit with this one. And in the next one, we're going to be looking at inheritance and kind of looking at how we can make it work with the human class as well.